So we had started looking at binomial random variables, binomial distributions, which means you have a fixed number of trials and you have either success or failure. And the random variable x measures your number of successes. So here we have a life insurance agent that's selling policies to 5 equally aged healthy people. According to recent data, the probability of a single person living for 30 years or more is 0.65. Calculate the probability that after 30 years, all 5 people are living. All 5 people are living. Okay, we're going to show you how to do this using binomial distribution tables. There are some really cool tables called binomial distribution tables. So they will be posted under the useful documents on Sakai. So you'll see a binomial link to a PDF. Okay, so success here, that means living, still living after 30 years. And failure would be dead, right? Dead before that 30-year period. So your random variable, x, that tells you your number of successes. So this would be the number of people still living, number of people living after the 30-year period. So what do we want? We want all 5 people living, right? So we want our x to be equal to 5. That's our goal. Now, how many trials do we have? How many trials? Well, there are 5 different people we have to consider, right? Person 1, that's the first trial. Person 2, that's the second trial. Are they going to be dead or alive? Person 3, that's the third trial. They're going to be dead or alive. Person 4 and person 5. So the 5 equally aged healthy people, that's our number of trials. We have to go through each individual. Are they going to be dead or alive? Now, what about the P? What's the probability of success on a single trial? So for one person, right? One trial would be one person. The probability of a single person living 30 years or more is 0.65. So there are 5 trials, right? 5 different people to consider. The probability of any single person living after that time period is 0.65 or 65%. And we're interested in the number of successes being 5, right? We want x to be 5. We want all 5 people to be living. So the way we write this, we write the following. The probability that x equals 5, that means what the probability that the number of people living is still 5 is equal to, we're going to go into a table called the binomial table. So I'm going to pull this up on my screen. Oops. See if I can scroll this. Here. This is my binomial table. Binomial table. There should be multiple pages to this. Yeah, there's a second page, and there's a third page. Now, I'm only going to use my second page. I'm sorry, my first page. Remember what n was? N was equal to 5. So here we're going to find n, right, equal to 5. And remember what x was. X was equal to 5. And remember what p was. P was 0.65. So when I put that all together here, I'm going to match all that up, and I'm going to get right here. And that gives me my probability, 0.116. So again, I found the n, which was 5. I found the x, which was 5. And I found the p here, which is 0.65. And I matched all that up. I got 0.116. So 0.116 is the probability that all 5 of those 5 people will still be alive after 30 years. So 0.116. That's it. Okay. Number 2. What's the probability that at least 3 people are living. At least 3 people are living. So again, success is living, failure means you're dead, and X is the number of people living, right? X equals number of people living after 30 years. Now, what do we want X to be? We want X to be at least 3. How do you say at least 3? It means greater than or equal to 3, right? You want X to be greater than or equal to 3. Now, how many trials are there? There are still 5 trials, right? There are 5 people we're considering. 5 healthy people. And what's the probability of success on a single trial? Still 0.65, right? The probability that a single person, just an individual, lives more than 30 years is 65%. Okay. So what we're interested in here is the probability that X is greater than or equal to 3. So that's going to be the probability that X is 3 plus the probability that X is 4 plus the probability that X is 5. It can be any of those, right? At least 3, right? 3 or more than 3. So it could be 3 people still alive, 4 people still alive, or 5 people still alive. So we're going to find each of those probabilities. So let's go into our table. We got to find 3, 4, and 5. Okay, so I'm going into the table. Erase everything so we can start over just to see how this works. So first of all, I'm going to look for my probability of... I'm going to look at my number of trials, which is 5 right here. Right, the number of trials is 5. Then I'm going to look up, let's see, 3, 4, and 5 for my x's. I have to look up all those. And then up here, the p, right, for the p, we have 0.65. So we're going to go down here. We're going to look up here, here, and here, right? We're going to have 3 numbers. First of all, for 3 people alive, you get 0.336. For 4 people alive, you get 0.312. And for 5 people alive, that's one we already done, is 0.116. So 0.336. Let me write those down, 0.336. Otherwise, I'll forget them, 0.312 and 0.116. So those 3 numbers. So that's for 3 people, 4 people, and 5 people alive. Okay, let me go back to my other screen. So here we are. So for 3 people alive, we had 0.336. For 4 people alive, we had 0.312. And for 5 people alive, we have 0.116. So we're going to have to add those 3 probabilities together to determine the probability for at least 3, right? 3 or more. That means 3, 4, or 5. 0.336 plus 0.312 plus 0.116. It's going to be 0.764. Okay, there's our answer, 0.764. All right. How about the probability number 3 less than 4 are living? Okay, so x is our random variable, our binomial random variable. That represents the number of people still living after 30 years, number of people living. And what we want x to be, we want it to be less than 4, right? We're interested in x being less than 4. What's the probability of number of people living is less than 4? Okay, remember the probability of success on a single trial, that's 1 person living more than 30 years, is 0.65. Oh yeah, and how many trials? N, right? N. So let's do the N first. N was 5, right? Right, there are 5 people we're looking at altogether, a total of 5 people altogether. It's our first person is the first trial, second person is the second trial, so on and so forth. The 5th person is the 5th trial. The probability of success on a single trial was 0.65. Okay, so we're going to look at the probability of X, number of people living, less than 4. So what could that be? That could be, X could be 0. That could be 0 people living, right? Plus the probability of 1 person living, plus the probability of 2 people living, plus the probability of 3 people living. So if you have less than 4 people, you have either 0, 1, 2, or 3 people living. So what we're going to have to do, we're going to have to go over in our table, look up 0, 1, 2, and 3. Probabilities. All right, so let's go back to our table. I'm going to erase everything and just start from scratch just so we're handy at using this. So the first thing you want to do, you want to look up your number of trials. You have a total of 5 people, right? 5 trials. Probability of success on a single trial is what, 0.65? So we're going to be somewhere down here. And we're interested in what? 0, 1, 2, and 3. It's going to be 4 numbers. Four numbers in the table, okay. Let's see. Need to erase some of that out of there. These are our 4 numbers, our 4 probabilities. 0.005 is going to be for 0 people alive. 0.049 is going to be for 1 person alive. 0.181 is going to be for 2 persons alive. And 0.336 is going to be for 3 persons alive. So let me write those down. 0.005, 0.049, 0.181, 0.336. Okay, so I have them written down. I'm going to scroll back to my other screen and write them in. So we got 0.005 is 0 people alive. For 1 person alive, 0.049. For 2 people alive, you got 0.181. And for 3 people alive, 0.336. I think that's one we looked up earlier. All we have to do is add those 4 probabilities together to get the total probability for less than 4 people being alive. 0.005 plus 0.049 plus 0.181 plus 0.336. 0.571. So in terms of a percentage, that would be around 57.1%, right? 57.1% chance that less than 4 people will be alive after 30 years from this group of 5 individuals.